Hey coders, you're watching the Coding Tree. This is Waleed and today we're going to talk about Spring Boot. It's the Java shortcut to build robust and deployable applications in a flash. It cuts through all the tedious setup and configuration so you can just focus on the fun and the most important part, and that is writing some awesome code. So therefore, the one word that really sums it up is effortless, because that's the idea behind Spring Boot, and that is writing and building your backend effortlessly. Now, whether you're a complete beginner in Java or just looking to level up your skills, this video is the perfect starting point for you. I'll be walking you through everything step by step, from setting up your environment to creating a Spring Boot application that is up and running within no time. Before we get our hands dirty by writing some awesome code, just hit that subscribe button and absolutely smash that notification bell for all the upcoming tutorials. So what are we waiting for? Let's get started and take on Spring Boot. Alright then, my friends, let's pull back the curtain on Spring Boot and see why it is one of the most widely used frameworks currently. It's like that cool kid at the coding party that everyone wants to hang out with. As I always follow the methodology, first the why, then the how. That is, let's first have a look at why we are here today and why you should be learning Spring Boot. Once that's clear, then we would move on to the how section, where I would walk you through how to actually do things the Spring Boot way. Here is a screenshot from the official Spring.io website where they say Spring Boot makes it easy to create standalone production-grade Spring-based applications that you can just run. We take an opinionated view of the Spring platform and third-party libraries so you can get started with minimum fuss. Most Spring Boot applications need minimal Spring configuration. So they are quite clear with the explanation here. That is, to create production-grade Spring applications, but more importantly, the focus is on doing it all effortlessly. The heavy lifting, the configurations, the class path scans are all taken care for you behind the scenes. All you need to do as a programmer is to concentrate on the job to do rather than worrying about or wasting your precious time on all those tedious chores. Here are some compelling reasons why having Spring Boot in your toolkit is an absolute must. Spring Boot skills are highly sought after in the job market. A quick search on any of the job portals like Indeed or LinkedIn reveals a large number of job postings specifically mentioning Spring Boot as a required skill. Spring Boot is used widely across the globe, spanning from startups and Fortune 500 corporations to government agencies. Amazon, Netflix, Bank of America, these are just some of the most notable corporations leveraging Spring Boot for building their backend applications due to its scalability and reliability. Spring Boot developers often pull in impressive salaries because their skills are highly sought after in the job market. So what does Spring Boot bring to the table from a developer's perspective? Let's first have an understanding of what the word bootstrap means. If you go and look in any English dictionary, it would tell you it's the technique of starting with existing resources to create something more complex and effective. That's precisely what Spring Boot offers, the ability to develop extensive and exceptional applications with all the essential resources readily available out of the box. You're still doing the same things you were doing with the Spring framework, but just that you would be doing it more effortlessly than ever before. So Spring Boot takes an opinionated approach. What does that mean? It means it has built-in default and preferences for how to configure and structure your application. It essentially means the framework makes some decisions for you, aiming to streamline development and avoid common pitfalls. Like for example, Spring Boot comes with sensible defaults for common tasks like database connections, security, and web development. This saves you time by not having to configure everything from scratch. For you to understand this clearly, let's talk about what sets Spring Boot apart with real-world analogy. Imagine you want to bake a delicious cake. And in the traditional way, like the spring way, it gives you all the ingredients, the flour, the sugar, and the eggs. Spring Boot, on the other hand, is like a pre-made cake mix. It comes with everything you need, pre-measured with clear instructions. And that's how Spring Boot streamlines things by giving you sensible defaults for common tasks, saving you tons of time and frustration. Of course, you can still add your own flavor if you're a baking pro. And in Spring Boot terms, that means you can still go ahead and customize the configuration. But for most developers out there, Spring Boot's opinionated approach is the perfect recipe for getting started quickly and building those awesome applications. Overall, Spring Boot's opinionated approach is a big advantage for most developers. It simplifies development, reduces errors, and makes your code more maintainable. This is a specific principle within Spring Boot's opinionated approach. It essentially means that Spring Boot expects certain conventions for how your project should be structured and coded. For example, specific class names and locations. That is, Spring Boot expects configuration files to be named and placed in specific locations within your project structure. Annotations for configuration. Instead of extensive XML configuration files, Spring Boot uses annotations to configure beans and other aspects of your application. What this means is that if you establish a set of naming conventions and put files in specific locations, you can substantially cut down on the amount of configuration that is required. Spring Boot is tailor-made for building microservices, which are small, independent services that communicate with each other. This architectural style has become increasingly popular for building modern applications. Imagine building a large house. Traditionally, you might build everything as one big unit. Spring Boot with microservices is like building the house in smaller self-contained sections like the kitchen, the bathroom, and others. And that's the great part here. Each section can be built and modified independently, but they all come together to form the complete house. Now that we are done with the why, we are ready to start exploring the how. By now, you would have got a pretty good idea about why Spring Boot has gained a lot of traction over the last few years and why it is the way to go for creating Spring applications. So let's find out what you need to know already and what needs to be installed on your system before you can start to code with Spring Boot. You should have a good understanding of the Java programming language and its core constructs. Having a knowledge of the Spring framework would help you substantially, but isn't required because initially I'll be walking you through the core concepts of the Spring framework, which would help you to get in a great state to understand Spring Boot much more easily. Again, a basic understanding of Maven would be nice, but if you're new to it, I'll leave a link to my Maven for Beginners playlist in the description below, and you can get a good idea of what Maven is and why do we use it. Having a prior experience of working of any of the IDEs like Eclipse, IntelliJ or NetBeans, but again, you can start right here, right now. I'll be using IntelliJ in this tutorial. You can use the same or STS, which is the Spring Tool suite. It is quite popular as well among Java developers. Or you can just even install the plugin for STS in VS Code, which is another IDE a lot of developers like to code in. You should have the JDK installed on your machine, preferably Java 17 or a newer version. You should also have a REST client tool like Postman installed for testing our REST APIs later on. In this series, I'll use Insomnia. It's a popular free and open source easy to use software. And that's it. We are done with all the intro and talking. Time to do what all you developers like to do, and that is writing some awesome code. So then, my friends, let's get started. So let's go ahead and open our IDE, and in our case, as I said, we're going to use IntelliJ in this tutorial, but you're just free to use any IDE that works for you, like STS, Spring Tool Suite, or even VS Code. And as I said, whatever works for you works for me. So on my system, I'm just going to open the IntelliJ IDE, and I have the community version installed. That is the free one. But depending on if you have the paid version installed, you can just open that one as well. So before we hit a new project here in IntelliJ, I'm going to just walk you through. And there are actually a few ways to create Spring Boot applications, and in this tutorial I'm just going to walk you through 2 easy ways to do that. The first way is to create a Spring Boot project through a tool called Spring Initializer. So head over to your browser, whether you're using Chrome, Mozilla, Safari, or Edge, and hit the URL start.spring.io as I would do right now. So that's the URL we're going to hit, and this opens up the Spring Initializer, which is a handy tool to quickly create a new Spring Boot project. Here we can easily configure our project with the essentials we need. So this is directly coming in from the official Spring team, and as I said, this is a really easy and a convenient tool to create your Spring Boot application or a project in just a few seconds. So let's first choose the version of Spring Boot you want to use right here, right? And the latest stable version is usually a good choice. Let's keep it to 3.2.4. And before that, the project, it's already selected for Gradle, but we're going to use Maven here. So that's why I'm going to select Maven, which is a common choice for creating Spring Boot apps, but you can just choose Gradle as well. And then language, Java, Kotlin, and Groovy are supported. We are going to keep it to Java for now. And then let's go ahead and put in our group ID. And this is like a unique identifier for your project. I'll just use com.walid for now, but you can just use your name and or your organization's name, and that would be fine. And artifact ID, it's like your project's unique name, and let's name it something appropriate like a Spring Web app, or you could just call it a Spring MVC app, because that's what we are going to create here. So name, I think it's just optional, but you can just keep it the same as artifact ID. Description is good. It sounds good. That is demo project for Spring Boot, because that's what it is. And package name, again, something appropriate in reverse domain, as is the recommendation. So we'll just keep it to com.walid.spring.training. Again, feel free to put in your own appropriate package names here. And then packaging, jar and var are supported. We'll just keep it to jar because, as I said, it just gives us a standalone Java application that we can just run. Then you can just select your Java version. 17 is selected, and we'll keep it to 17. But at the time I'm recording this video, Java 22 was just released a couple of weeks back, and you can just select that as well. It is now supported, but for the sake of this video tutorial, we're going to keep it to 17. And then the real power of Spring Initializer comes from its wide selection of dependencies. These are pre-built libraries that add required functionalities to our application. We'll keep it simple for now and search for and click web, because that is we're going to create a Spring Web application. So just go on to this add dependencies and just search for web. And this is the first result that you're getting. It says build web including RESTful applications using Spring MVC, uses Apache Tomcat as the default embedded container. So this is the one we're going to select for this project. And otherwise, you can just have a look at a host of many dependencies right here coming there for you in a really nice to look at manner with Spring Initializer. All right. So Spring Web is selected. If later on you want to delete this, remove this, you can just hit this icon. But for now, this is good for us. So then we can just go on and click on generate. And what it would do is it would just create a new Spring Boot project depending on whatever settings we have put here, and the dependencies would be included as well in our project. And then it's going to get us a zip file, download it on our system, and then we would need to unzip it, export it in our IDE, and then we'll be able to run it. So let's just do that. I'll just hit generate, and it has been generated. But you need to know that behind the scenes it's just a Maven project which has been now customized to act like a Spring Boot project thanks to your settings and just one dependency here. So I've now gone on to my downloads folder, and you need to extract this like I have, and you're seeing that this has the POM XML in the root of the project that tells you it's just a Maven project. So you just need to export this in your IDE. So let's head over to IntelliJ, and this time we're just going to hit cancel, and then we're going to say open, because we're not going to create a new project. We're just going to import in our IDE an already existing project, and we'll go to downloads and just go to the root of this folder and just say open. And it says, do you trust this project, that is Spring Web App? We'll just say yes, and it's just going to open this in our IDE. And again, we're just using IntelliJ in this video. So it's syncing up the Spring Web App project and resolving dependencies, downloading some stuff. Let's just wait for this to finish. And once it's done importing the Maven project in IntelliJ, we would just be able to run it, because that is the advantage we get with Spring Boot. We get a project that we can just run with zero or with very minimal configuration. Because remember again what I told you earlier, the focus in Spring Boot has always been convention over configuration. So you get this project, right? It's a Spring Web project. You get the POM XML, and you can just go on and run this. Source main Java com.walid.spring.training, and this is your main file. In some time I'll just do some explaining for you on these couple of lines what is going on here, but for now you can just go on and just hit run. And just in 1.6 seconds it says started Spring Web application, or in just 1.273 seconds, right? So with minimal of fuss, you're able to create a new Spring Boot project which you can just run, and your project is running. This is the proof of that. All right. But before we dive into more specifics about this project, what the different files are and whatever the configurations are going on behind the scenes for us, I'll just tell you about the second way of creating a new Spring Boot project and why that is my personal preferred way of doing that, right? So for that to be done, let's first go on and stop this project, and you can then go on and close this project. And the second approach is you can just create a new project in your IDE from Spring Initializer, but that would all be taken care of within the IDE. See, you can just go on and click on new project and just select Spring Initializer here, right? Not Maven archetype, but Spring Initializer. So project SDK again, let's keep it to 17. See, this is familiar now. Default start.spring.io. It is the same URL that you hit in your browser for going to Spring Initializer. And this approach, this has you hitting this URL from right within the IDE. And I'll tell you once we create this project what the advantages are. Hit next, and it says group ID again. Let's quickly keep it to com.walid as we last time did it on the Spring Initializer website. Artifact ID, I'll just again call it Spring. Let's call it app web. Version, let's put it to 1.0.0. Project type, you can keep it to Maven. Basically, you're getting these same settings as you were on the Spring Initializer website that was the wizard, but here you're just seeing them within your IntelliJ IDE, and you will see a similar pop-up window in STS or VS Code if you're using those IDs, right? So the same settings you were getting on the Spring Initializer website, they're now here within the IDE. Language Java, again, Kotlin and Groovy are also supported. We'll keep it to Java. Jar is good, Java version 17. Project name, let's again put it to the same as the artifact ID. I'll just call it Spring app and web. Project description looks good. Project name, again, let's put it to something relevant, com.walid.spring.train. And we'll hit next. And now see, the dependencies section now is the same as you were getting on your browser window, but this is the wizard in IntelliJ, right? And we just go to web and just select Spring Web. And once you hover on this, or once you select this, it says the same thing, build web including RESTful applications using Spring MVC, as it was saying on that start.spring.io Spring Initializer homepage. Basically, it's the same thing. The difference is you're getting all of that in your IDE. So we'll select Spring Web for now, not other things, because again, we want to keep it simple. Hit next, and project name is good. Project location, let's put it to downloads folder on my system, and then hit create. And you got it, Spring App Web, that is the Spring App Web, sorry. And just click on this load Maven project. Okay, because remember, behind the scenes, it's just a Maven project, right? And you get the source, main and Java, and we'll just hit run. And again, it says that Tomcat started on port 8080 and started your Spring app web application in 1.853 seconds, right? So again, you get a Spring Boot project out of the box, ready for your Spring web application, and with minimum of fuss, and it just runs, because we have not even written one line of code yet, but we just are able to run your project out of the box. So now, why I said that this is the preferred way for me to create a new Spring Boot project, and for you it would be the same, because the first way was good. That is, you're going to your Spring Initializer website, that is start.spring.io, but then you need to put in the settings here, select the dependency, then you need to hit generate, which creates your project, and then zips it, downloads it on your system. Then you need to head over to your downloads folder. You need to unzip this particular folder as we did, and then you need to go to your IDE, and then you need to import it, and then you need to run it. So you saw that, right? There's a lot of steps there. But the other approach, that is this particular approach that we took, that is what we did is we just went to our IDE, and all we did is we just said new project and went to Spring Initializer, kept the default start.spring.io here, hit next, put in the same settings that you did on your browser, on your external browser window. The same settings are being displayed here. You can just put them here in your IDE window, and hit next and hit finish, and then you get a project that you can just run. So all of this stuff is happening right within the IDE, instead of you going first to a browser, hitting the URL, putting in the settings, generate, and then it zips it, downloads it, you unzip it, you import it, and then you run it, right? A lot of steps there. But here, just right within the IDE, you're able to do all of that, but with again minimum of efforts. That's why this would be the preferred way of creating a new Spring Boot project. That is, you can just do it with any of the IDs that you're using, whether again VS Code, in my case IntelliJ, or STS, right? Now that we have got our project created, let's go on and let's have a look at a couple of important files here, starting with pom.xml, which is at the heart of any Maven project that you would create, and that is where you put the majority of the stuff for your Maven configuration. And you can see that whatever we were putting in through the wizard is right here for you. That is version is 3.2.4, then group ID, com.walid, artifact ID, Spring App Web, version, name, description. That is, if you still want to change anything that you put in the wizard, you can still do it after you're done creating the project. And then the properties, that is Java is set to 17 for this project. Again, if you want to change it, you can change it right here. And then in the dependencies section, you've got a couple of dependencies here, but the one in focus is the Spring Boot Starter Web. Now Spring Boot provides you a number of starters that lets you add jars to your class path. These Spring Boot starters are pre-configured dependency bundles that simplify the development process for Spring Boot applications. Instead of manually adding individual libraries for various functionalities, you can include a starter with a single dependency in your project's pom.xml file. Like in our case, we have added the Spring Boot Starter Web, right? Because we are creating a Spring Web MVC application, and adding just this one Maven dependency to our pom.xml gets us all the jar files required to create a typical Spring Web application. Like it already has the Tomcat as the embedded server. There are other libraries like you can just have a look at in the external libraries section. See, this is a lot of libraries out there, but you just added one Spring Boot Starter Web in the dependencies section of your pom.xml file. So this is the magic of Spring Boot for you. It has the Jackson there for the marshalling and the unmarshalling for JSON to Java and Java to JSON, which we'll have a look at later on. It has the ByteBuddy library. It has Apache logging. It has JUnit if you want to do testing, which is inevitable because we developers have to write a lot of test cases. It has Spring Framework.boot Spring Boot 3.2.4 because that's the version that you selected. It has support for AOP, Beans, Spring Framework, Spring Web, and all of the other stuff hidden for you behind external libraries. But my point here is you just added one of them, that is Spring Boot Starter Web. Remember what I told you earlier about bootstrapping Spring? This is what you're seeing here. And similarly, like we added Spring Boot Starter Web because we want to add it for creating a Spring Web MVC application, there are other starters available for other functionalities, such as let's say you want your application to connect to a database and you want to use JDBC or JPA. There is a particular starter for that. You want to have one for web development, as we are having Spring Boot Starter Web. But if you want to, this one is for Spring MVC, but let's say you want to create Spring reactive applications, then you have one for Web Flux. And then let's say you want to incorporate Spring Security, there is a particular starter dependency for that. Let's say you want to add support for messaging like Kafka or JMS or RabbitMQ, there are particular starters for those as well, and many more. And you're going to use more as you keep writing more code with Spring Boot. For now, in the context of this tutorial, we are keeping things simple, and the Spring Boot Starter Web just suffices. So next, let's also have a look at our main file. That is the one that we ran, right? We just hit that run here, and it just started it in around 1.8 seconds. So this is the entry point for our Spring Boot application, that is this particular file, because it has the classic traditional public static void main Java method, and in a typical Spring Boot project you will find the main class inside the root package, and in our case that is inside com.valid.spring.training. That is as I said, the main class should be in the root package, because this is by convention, as Spring Boot often scans for components based on package structure. Having the main class at the root ensures it always is included in the scan. Now notice the Spring Boot application annotation on top. This is what tells Spring Boot that this is the main application class. This annotation essentially does a lot of configuration behind the scenes, enabling features like automatic component scanning and automatic configuration. Remember, I spoke at length about convention over configuration and how Spring Boot does a lot of magic under the hood. That is what's happening right here. This annotation is known as a meta annotation, as it is a combination of three annotations, that is Spring Boot configuration, enable auto configuration, and at component scan, which combines several functionalities like it enables auto configuration, which reduces boilerplate code. It also enables component scanning, which is used to find Spring beans, and it also configures the Spring application context for you. So if you hover on this, that is what it tells you. See, Spring Boot configuration at enable auto configuration at component scan. That is what I told you. It's a combination of these three annotations. That's why it's called a meta annotation. So it basically tells Spring Boot to guess how we want to configure Spring based on the jar dependencies that you have added. And since Spring Boot Starter Web added Tomcat and Spring MVC, the auto configuration assumes that you're developing a web application and sets up Spring accordingly. So you see a lot being done for you behind the scenes. Next, the public static void main string array arguments method is the starting point of our application. This is where execution begins when we run our Spring Boot application. That is when you hit this run button. Right? So Spring Boot provides a convenient, if you see the run method here, yeah, that is what is being provided by Spring Boot. It's a convenient run method from the Spring application class. We call this method passing our main class as an argument. That is what I'm doing here. And this tells Spring Boot to launch our application with all its configured functionalities. So that's about it. The Spring Boot application annotation sets everything up, and the run method ignites the engine for you. And all of this is done for you automatically. Remember, we still have not written a single line of code yet for getting our first Spring Boot app up and running. And here I was just walking you through about the main parts of any Spring Boot project and what goes on behind the scenes for you. So we had a detailed look at why this is the preferred approach of creating a new Spring Boot project right within the IDE. And then also we had a look at the main parts of your any Spring Boot project, that is the POM XML, what goes in this file, and what are the starters, the Spring Boot Starter Web, and any other starters that you need. And then we had a look at what the main class is about, what this annotation does, and what does the run method does of the Spring application class inside your public static void method. Now that we have a basic Spring Boot project up and ready, we want to see something live, right? Instead of the console just telling us our app is running on port 8080. If we go to our browser and hit the URL localhost 8080, let's in fact do that. I'll just say localhost 8080, hit enter, and we get a 404. And that is the resource we are looking for was not found. And that should not come as a surprise because we do not have anything there yet. And that is where our next part of the tutorial comes in, and that is creating a REST API with Spring Boot, which is the core part of any Spring Boot application. And before we start creating a REST API, it's a good time to understand quickly what a REST API is. So in today's world, applications often need to communicate with each other and share data. This is where APIs or application programming interfaces come in. They're like tools that act as messengers, allowing different software components to exchange data and functionality. And REST APIs, which stand for representational state transfer, are a specific type of APIs that follow a set of rules for how that communication happens. It uses familiar HTTP methods like get, post, put, and delete to interact with data in a structured way, and responses often come in JSON format. REST APIs are designed to be consistent and predictable, which makes them easier to learn and use. REST APIs can handle a lot of traffic and grow as needed. That's why they are scalable. They work across different platforms and languages. That's why we like to call them as interoperable. And think about it as a waiter taking your order in your favorite restaurant. That would be your request. And when the waiter brings you back your food, that is the response, right? That's a simple analogy to have a good understanding on what a REST API is. Or you come across many real-world examples these days where you are using a particular app and that app in turn is getting some data from another service. That is where those other apps are exposing their functionalities through REST APIs. Take, for example, weather applications, which rely on weather service APIs to retrieve up-to-date weather data for your location. Or even online maps, like Google Maps. They offer REST APIs that allow embedding maps into website or applications. Ever booked a ride with Uber? And you will know what I'm talking about. Or even payment processing, where many e-commerce websites or apps like Amazon use REST APIs to connect with payment gateways like PayPal or even UPI to process customer payments securely. So now that we are clear about what a REST API is, let's start creating one with Spring Boot. And you will see why I say it is absolutely effortless. And we are focused back on our IDE, in our case that is IntelliJ, and where we are going to create the Spring Web MVC application. And we already have our app started on port 8080, but if you remember, we were not able to hit any of the URIs on our browser because we said localhost 8080. It resulted in an error that is 404 because the resource we were looking for was not found. And as I stated earlier, it should not come as a surprise because we did not create a mapping yet, right? We did not expose any of the REST endpoints until now. So this is a perfect moment to expose some part of our functionality as a REST endpoint so that someone else can consume it, right? So I'll be focusing on more here on these two words, that is expose and consume. So expose will be exposing the functionality from Spring Boot, and consume is where we would, for starters, consume it from your browser, and that browser can be Google Chrome, Firefox, or even Microsoft Edge. So we'll go back to our IDE and quickly I'll just make some changes to my main class, and on top of this I'll just use @RestController. So this comes from org.springframework.web.bind.annotation.RestController, and this is a class level annotation. I put it on top of your class, right? So this is the annotation which you put on a class where you would later on have methods which would map to URIs that you can just hit from browsers or later on from your frameworks such as Angular or from JavaScript libraries like React or even from vanilla JavaScript. So on top of these classes, you have to have the REST controller annotation. And this is also called a stereotype annotation. It serves basically two purposes in terms of Spring. this is the class which plays a specific role. As I said, in this class you would have some incoming HTTP requests taken care of. And the second purpose is anyone reading our code would just get an idea this is not a normal ordinary class, but it is a controller in a Spring web application. Right. So then I would have a method inside my main class apart from the main method, and I can call it anything, and we'll just return a string, and I'll just say get message. Just a normal ordinary method. Obviously calling it appropriately serves the purpose, right? Get message looks like we are sending back a message, and I'll just return a sample string. Quickly I'll say return, this is our first Spring web app. So this would serve as a REST endpoint. How is that exactly? Because on top of it, I'll use another annotation that is at request mapping. Now, what does it do? You put in along with the request mapping, you say URL to map. Right? You put in the URI that you want this method to be mapped to. Because remember, this time we're not going to call this Java method from another Java method or class, but from a browser or from a JavaScript setting. Right? So this is going to be different. And this basically tells Spring to execute this method upon hitting the URL. When a request comes through this URI, this is the method to be executed. This is the method to be called. So this annotation, by the way, it only maps to get method by default, and you have to specify otherwise, which we'll be doing later on. And Spring automatically scans these annotation classes and registers them, because remember I talked about auto configuration and automatic ability of Spring Boot to scan for all these kind of annotations. Okay, so in simpler terms, this request mapping, as per the official documentation, this annotation provides routing information to our application. Right? So it tells Spring that any HTTP request with this particular URI should be mapped to this method in our case. And the REST controller annotation also plays a part here, because it then tells Spring to render the resulting string, because remember we are returning a string here. So it tells Spring to render the resulting string directly back to the caller, whoever that caller is. As I said, that can be a browser in a case, or it can just be coming from an Angular application. But these two play together, that is REST controller at the class level and request mapping at the method level. And all you need to just do is you just need to run the Spring app web application again, that is relaunch this. I'll just do that quickly. And as you're seeing, Tomcat started on port 8080 again, and our application was started in 1.9 seconds. Let's now go back to our browser. And this time, if you hit the URL again, localhost 8080, you would still get the error 404, because on this URI, there is nothing mapped still. But we have a REST endpoint, and that is listening on / did we put something there? We just said URL to map, which I was just telling you about the syntax, but let's give it a better name here. I'll just say /message, and we'll just rerun the application. So when you hit localhost 8080 /message, this time you should be seeing this particular string returned back to you. Let's see if that works. The application has started again, and let's say /message. And you absolutely see that, right? So this is our first Spring web app on your screen now. So because what happened is, as I said, we told Spring to execute a particular method upon hitting the URL, that is /message. and it's a get request by default. So now you're able to at least see something apart from just the console message that just told you repeatedly Tomcat started on port 8080 and your application was started in 1.9 seconds. But now we are seeing something concrete here. So we have got our first REST endpoint exposed and we are consuming it through a browser. And this is where we saw a returned message from our REST endpoint, and that is, this is our first Spring web app. So now it's a good time to focus on a real world example, and we'll be creating a REST API for a resource. And the resource now, what is a resource? Resource can be, it can be you are creating a REST API for users, you're creating it for, let's say, monitors, you're creating it for your customers. It can be anything that is dependent on your requirement. So the REST API we're going to create here is for learners. So let's say we've got a list of learners. Later on, it would come from a database. But in this example, we'll just focus on the Spring Boot side and how to create a REST API in Spring Boot. And we've got this data of learners that we want to expose through different REST endpoints. And then we're going to consume it from the front end, and for starters that can be a browser, and then later on it can be from JavaScript or Angular or Vue or React. So as I said, in our case, the resource is a learner, right? And we are going to create a standard REST API for learners. So learners is a resource, and generally we should put in relevant names, relevant identifiers again to whatever you're doing, and learners looks good here, and it would just be a standard REST API with different REST endpoints. And starting with, let's say you want to get a list of all the learners. So we'll be having the URL like this. We'll say /learners, which would get you all learners. That is, whatever there is in our database or in our list or in an array, it would be returned as a complete learners array. And when the client would hit the URL that is /learners, this is what they would get. And this would be using a GET request, because in a REST API, whenever you're fetching or reading resources, you should always do that with the GET. And GET, by the way, as I said previously, it is the by default way of hitting a URL, right? And just a point here on why did I call it learners and not learner? Because we should always prefer using nouns, right? That's the first thing. The second thing is, generally the industry standard is we go with plurals like learners, users, laptops, cricketers, and similar resources, similar naming schemes. That is, we do not prefer using learner or user or monitor, but go with plurals. That is just the industry standard way, and that is what we use or what you would come across a lot. But sometimes if your team decides to go with let's say the other way around, that is naming it in singular, that's fine as well. But generally, if you're getting all the resources, all the learners in this case, we would prefer using learners. And I would just tell you to keep it consistent, to keep it uniform. Let's say you use plurals, then you should use plurals all the time. Otherwise, if you go the other way around, singular, then singular all the way, right? So that's our first URL. When the user hits /learners, then we should get all the learners. The second one, the second REST endpoint that we'll be creating is /learners. Again, I'm going with plurals here all the way just to keep it uniform, and then /id. And when the user hits the URL /learner/id, he or she should get one particular learner by the particular ID. So I'll just say get a learner by ID. And this would again be get, because we are still fetching or reading resources. And this ID would be unique, okay, as is the case usually. And based on that particular ID, we would just get one particular learner, not all the learners like the first REST endpoint. The third REST endpoint in a REST API would be again /learners. And when someone would hit it, we would be able to add a new learner. And this time the method we'll be using, REST method, is post, because whenever you are adding a new resource, and in this case our resource is a learner, we want to add a new learner by hitting this URL, we should always use the standard REST method, that is post. Never get for this. Okay, and now you might be wondering, this for the first REST endpoint and this exactly looks the same, wouldn't there be ambiguity? The answer is no, because the calls, see, the URLs are the same, but the calls to these two different REST URLs or URIs are resolved by the method that you're using. And in the first case, it is get. In the second case, it is post. That's why there would be no ambiguity. This would just read all the learners, and this would just be able to add a new learner in our backend. And recommended is you should keep it the same, that is /learners here, /learners here. Okay, then the fourth REST endpoint will be exposing is for /learners, again by an ID, because this time we want to update a learner, that is update an already existing learner by his or her ID, and this time we should use the standard REST method, that is put. Again, you will see that is this and this exactly looks the same, but no ambiguity thanks to the methods being different. Here it is get, here it is put, because put we always use it for update. And the last one as part of a REST API is for deleting, and we'll keep the URL the same as for updating, that is learners /ID, because generally we delete or update by an ID, and this would be used to delete an already existing learner. And the method we'll be using is appropriately called delete. Again, no ambiguity because the methods are different, right? So 5 REST endpoints will be exposing for someone else to consume them later on. And based on the URLs, based on the methods, appropriate functionality would be exposed. So this is what is on the agenda. This is what we'll be creating with Spring Boot, and you will see and you'll come to know how easy Spring Boot makes it to create a REST API for you. So let's just actually do that. Let's head over back to our IDE, and for now I'll just comment this REST controller, I don't need it, and comment this as well, or just delete it because we don't need it. And because this main class, let's just let it do what it is meant to do, and that is it should just act as an entry point for our Spring Boot application. And instead what we'll be doing is we'll be just creating a new package and a new class for learners. So first I'll create the package in IntelliJ. I'll just call it com.valid.spring.training, where my main class is, and then dot the sub package that is appropriately called learners. And the learners package, I'll just be creating a new Java class, and I'll just appropriately call it learners controller. Okay, and on top of it, what makes it extraordinary is just one annotation. You know that now, that is REST controller, which would give me the flexibility to have certain methods in this class which would intercept incoming HTTP requests, from different URIs. So this is the benefit of having REST controller at the class level. Okay, and then I'll just have the first method, as I said, what we'll be creating is /learners. It should get all the learners. But wait a minute, we don't have the data yet. As I said, in a real world program, in a real world application, the data would come from a database, a SQL or a NoSQL database. But currently, because we are just focusing on Spring Boot and how to create a REST API with Spring Boot, so I don't want to go into the database part. There is a separate video coming on for that. But for now, we'll just have a static data, that is a static array list of learners, and I'll just create it statically for you. I'll say a list from java.util, and let's create a type learner. And this learner class, I have not created that yet. Just wait for me. I'll just do that in some time. So I'll just call it list of learners appropriately. And then new array list from java.util again. And then we'll just have a static list of data here. I'll just say arrays dot as list, where I can just have different learner objects into this array list. But first, let's go on and create this learner class. So I'll just say more actions and then create class learner in the same package com.valid.spring.training.learners, because this is appropriate to learners. I'll hit OK. Yeah, this is what we've got. And in this learner, what you can do is you can create a Java 16 record rather than having a complete Java bean. So I'll just say a record learner. And if you're new to learners, there's a separate video I've created for records. I'll leave the link in the description. So I'll just say record learner, and then the fields I'll say, let's say integer ID, which would be unique to a particular learner, and then string learner name, and then we'll say string learner skills. All right. So this looks good. Integer ID. What do we have got wrong here? Okay, let's have it like this. So, and if you already know how a record works, the fields that you declare here are implicitly private and final. And this learner has a canonical constructor that is the same way as you are having the record header. That is, it would be the same as ID, name, and skills. And it's just a great way to avoid verbose code. It's a great way to avoid boilerplate code the way we did with Java Beans. So turning our attention back to learners controller, you see the error is gone. This is a list of learners. Let's just add some learners here. I'll say new learner. And with the fields, the first one is an ID, the second one a string name, and the third one a skills. And I'll just copy paste this. Somehow the shortcut for copy paste isn't working. Okay, let's have it like this. Let's have 4 learners at least, separated by a comma. Okay, so and let's have some random IDs. I'll say 56, and the learner name is, for example, John. And I'll say skills, C, C++. And the second ID, let's have it quickly, 432, with the name, for example, Nargis, and the skills as Java J2EE. Similarly, we'll have 2 more learners quickly. Let's say 451. The name is, let's say, Sandeep, and we'll have HTML and CSS. And the fourth learner in our data. Remember, this will later on come in dynamically from a database, but for now, we just have a static list of learners. And I'll just say 578 as the ID, and then let me have it as Abhishek, and we'll say just Java. Okay, we have this list of learners now ready, and now let's have our first REST endpoint exposed. I'll just have it as void because I don't know what would be returned. So always better to play it safe. Just have it as void and then let the ID do the transformation for you. So I'll say void get all learners. Right, I'm calling it appropriately, doesn't need a parameter, and it should return the complete list. I'll just say return list of learners and just change the return type to a list of learners. That's it. But remember, just naming this appropriately is not going to suffice. What you put in the request mapping, the URL to map, is going to work for you. That is, on that URI, the request is going to be intercepted. So I'll just say at request mapping, and I'll just say, as we discussed, it should be /learners, right? So I'll just say /learners, and a good recommendation is that you should have your versioning as well. So I'll just have at the class level at RequestMapping. This is important because you want to not break changes, and you want to have different versions for different upgrades and updates. And also, let's say you have multiple controllers in your application, so you would be able to segregate different controllers based on the starting URI. So I'll just say request mapping, and at the top I'll just say please have it as API slash v 1.0. Right? So now anything coming to /learners would not just be localhost and port and /learners, but it would first need to come through API slash v1.0 /learners. And let's see if we get what we are after, if we get all the resources for us, and the resource in this case is a learner, right? And we'll just rerun this application. The build would start shortly, and our application should hopefully start again on port 8080. And by the way, we can just change the port as well later on in application.properties. There is a file in the resources folder, but for now this is fine. It runs on port 8080, and we'll head over to our browser and see. /message would not work because we have deleted that, but now 8080 /API v1.0 /learners. Absolutely wonderful stuff. This why? Because you're getting it as a JSON array with JSON objects. But this would not be the same if you run it on a different browser like Chrome. See, hit the same URL. Yeah, this is how you get it. That is, it just looks like quite pretty raw, that is, but you can guess it. This is a JSON array, and the curly braces, sorry, they represent one JSON object with saying ID 56, name John, skills C++, ID 432, name Nargis, skills Java J2EE, and then Sandeep and Abhishek. These are 4 JSON objects returned in a JSON array, but Firefox makes it really good for you because you're seeing it in a pretty format here. See, more like a JSON array with JSON objects. Say 0, 1, 2, 3. These are the array indexes. So that is, we're getting 4 JSON objects in the JSON array. And for John, Nargis, Sandeep, and Abhishek, whatever our data was, we are getting that as JSON. But wait a minute, who did that for us? Because we just returned in our get all learners method, we just returned a java.util.list of learners. But how is it getting a JSON array for us? Right? This is the magic of Spring Boot. You don't need an external library to do that. That is, it does automatically the marshalling and unmarshalling from the Java object to a JSON array, or vice versa as well. This is where Spring Boot comes into picture. It does it automatically for you. It knows that JSON is the standard format for communication these days, the modern way of communicating, and then it does the marshalling and the unmarshalling from a Java object to a JSON array, or from a JSON object to a Java object automatically for you. Because remember, you're just returning a Java object, but on the browser, you're getting it as a JSON array with 4 different JSON objects. That is the beauty of Spring Boot. Remember, my word was effortless, and this comes to the fore right now. So our first REST endpoint is done and dusted. We were able to fetch all the learners. Let's focus on the second part, that is getting a learner by ID. And this is what we are going to put the URI like, that is learners, again in plurals, with /ID. And the method would still be get. So let's actually do that. And I'll just have one more method. Again, I'm not sure. Let me just go with void. I'll say get learner by ID. And we'll just pass in. This time we would need a parameter, right? Because we would need to search it on the basis of ID. So I'll just say integer ID, and then the logic to search on the basis of ID. And I'll just use Java 8 streams and lambda syntax to just make it look to make it just work as a one-liner. So if you're new to Java 8, you can still use pre-Java 8 code with the enhanced for loop and the logic. But this is just one-liner. I'll just say return list of learners dot stream. Let's get a stream out of it. And then I'll just say filter, and we'll pass in, I'll say ref or lambda. I'll say ref dot id dot equals id, that is the one that I'm passing. Please search it within the stream, within the array list, and then I'll say dot find first dot get, and see what is it returning. One particular learner on the basis of the id that was found. And if this is the case, just make the return type change to just one learner. All right. And remember, it won't work if you don't put in the request mapping. So I'll just say request mapping, and this time the URI, what we would make it listen to is, again, as I said, learners slash ID. But if you put it like this, and on the browser you hit learner slash the string ID, right, it won't work, because we need an ID like 578, 432, or 56 for it to be able to searchable in the array list. So how would you make that happen is you'll use here, you'll encapsulate this ID within curly braces, right? And then how would this ID be passed to my method argument ID? Through another annotation called @path variable. This is the one. And if you hover on this, it should tell you, it doesn't tell us the documentation, but this is path variable. That is, it just, because this is now acting as a placeholder, a variable in the path, right? So that's why it's called a path variable. And this is just mapping this ID to this particular argument ID. And then I can write my logic. Let's see if the second one works as well. I'm again going to rerun my same application, and in just a few seconds it should be up and running on the same port 8080, because remember, we did not change the port yet because we did not need to. So it says Tomcat started again on port 8080. Let's head over back to Firefox. This one should still be running, and it is, right? And now if I'll just copy this URL, open a new tab, and I'll say /learners/id, I'll say 56, and off you go. We just get one particular learner in the most convenient of manners, because we did not have to do much. You just use @requestMapping, @path variable, and then pass the ID to search, and this is what you get, right? In a really nice format in Firefox, that is 56, the ID that you searched for, John, with the skills C and C++C. And if you search for 432, the second ID in your list, and you just get the learner object for Nargis with all the details related to a learner, that is Nargis. 432, Nargis is the name, and skills are Java and J2EE. That means the second one is done as well. Let's focus our attention to the third one quickly, that is add a new learner object now. So we head over back to our IDE and put in another REST endpoint, this time for adding a new resource. And in our case, that resource again is a learner. So we want to add a new learner that is not already existing. So for now, we'll just keep it to void, because this time we're not going to return anything back, because we're just going to take a new learner object and add it to our list. So I'll just appropriately call this method as add new learner. And this time, any guesses? Do we have to have an argument here? Yes, we do. And what kind of an argument that should be? It should be of the type learner, because that's what we are trying to add, right? So I'll just have it as type learner, and I'll just call it learner. And then all you need to do is you just need to say that is list of learners dot the method add, which is a method of the list which takes a learner. I'll be passing a learner, and that's all. Now, what is the request mapping going to be here? So first of all, let's have the annotation again, request mapping, and then we're going to have the URI, the route path as again learners, because remember what I told you about, that is how this is going to look like. See, whenever someone hits /learner, it is going to add a new learner, as well as /learners is mapped to another method that is get all learners. But how would they be segregated is through the method. That is, this was get, which is by default, but this time the request method type has to be post. So how do you put it here? Because by default, as I said, request mapping is get. So if you have to have a different type, you have to specify it. So how do we specify it in request mapping? You just say this becomes value, and then you say method. What is the method that you're using? And that is request method dot post. So this time, because we are having a different method than the default get, that is in this case it's post, that's why I had to put in the key and value pairs. The key becomes value to the path and the routing path, and then request method dot post is for the key, that is method. Or you can even put it in short as just saying, instead of request mapping, I'll just comment this. This will be short. I'll just say add post mapping. Right? And then you'll just put in your path, and in this case, that is learners. What this does is, this is just generic, that is request mapping, and this is more specific. It is better readable and it does the job as well. You don't have to specify the request method dot post here, the value here, just the path and then the post mapping, which maps to the post method. That is the incoming request, which is of type post, this method would be executed, and the request mapping, which is of type, the method is get, this one would be mapped. And there is a specific one for get as well, and that is at get mapping. Right? Better readable and does the job. But this time, doesn't make much of a difference here because it's just by default to get, and there is the path that is learners, so you can choose either of these two. I'll just keep it to the generic request mapping here, and then here I'll just keep it to post mapping because we are having the post method here, and any incoming request that is of the method post would be intercepted with this particular method, which would take a parameter of type learner. And this time I can't pass in the learner complete object as part of the variable here, right? Like we did for get learner by ID, because this was just one argument. But here it's a complete object. So for that, there is another annotation that you'll use here, and that is at request body. Which generally precisely tells Spring Boot that this method is going to take an argument, the complete learner object, the complete learner that is the resource, as part of the body of the request, not as part of the path, right? That's what is different here. And then that's it for us on the Spring Boot side. Now let's see how do we do it on the front end. And currently we are doing it through the browser, if you would remember. So let's wait for it to build and rerun the application again. Should be done in just a couple of seconds, and we would be ready to run this request again from the browser. So it says again Tomcat started on port 8080. So what we'll do is we'll head over to our browser. These two REST endpoints are still working. See, we're still getting 4 JSON objects, and with this one, the particular JSON object by the ID. And now what I'll do is I'll just copy this until learners and hit it. So what would happen is, just remove the slash, it would still get me all the JSON objects. Why? Because what happens is, by default, as I said, it's of type get, and this is the one that is listening to it. So how do I make it map to this one? That is, how do I tell the browser that this is a post request? So turns out later on, when you would be creating, or when you would be getting your request from a front end framework or library like React or Vue or Angular, then you'll be submitting the request as a form, as part of a form. But currently we don't have a form here in our browser. So that's where, as I told you in the prerequisites section, we need a REST client software like Postman or Insomnia to test our REST API calls. And that is particularly true for any post or update requests. but it's a complete software. It helps us with making REST API calls for get, post, put, and delete, and all the REST methods, right? But for this time, we're going to use Insomnia precisely for a post request, and I already have it installed. Let me just head over. This is the icon that you'll get once you install Insomnia, and this is where you put your requests. See, I can just paste it here. API learners, by default it's get. If you would send, you say 404. Why is that? Because yeah, remove the slash at the end. So you get them in a nice looking format here. Says 1, 2, 3, and 4 are returned, and 200 OK, which means the request has succeeded. Whenever it's a green, it's a 200 OK. That means your request is a success. And it took these milliseconds to get it, and that's it. And what you can now do is you can even create another request. Okay. I just hit Control N and I'll say Control V slash, and we'll search for, let's say, 451. You get Sandeep with his skills and ID. And if you just want to go to the first one, just click this one and you get it. And you can even rename this. I'll just say, let's try to rename it. I'll just call it get all learners. And for this one, we'll say get learner by ID. So those are the advantages of having to test your REST API with a complete REST client software like Insomnia. So then you know by the name what this request does, what this request does, and all you have to do is just click on this and say send, and you get the response on the right side. Similarly, we are going to create one more here, and HTTP request, and this time we're again saying Control V, and this time you're going to select post, and see, it's very convenient to select other REST methods from the list here. So I'm just going to click on post. This is a post request, and this time we are going to add a new learner object from Insomnia. And that Spring Boot STS or Eclipse or IntelliJ in our case, it's ready to take in that object as a request body parameter. So what you're going to do is just click on this body here and click on JSON. Yeah, and just put the object here. And let's go on to get learner by ID. Just copy this response, go to the post and paste it here so that we have the structure that it takes. So ID is, let's say we are doing 101 and a new name. Let's put it to Walid, and the skills to, let's say, Python, Java, and PHP. So this is not there in the list. Just click on this and hit send. See, we just have John, Nargis, Sandeep, and Abhishek. But now when I click on this and I also rename this, I'll say add new learner. Hit rename. So it tells you, just having a look at it, what does it do? Click on this and hit send. If we get a 200 OK, we know our request was a success, and it says nobody returned for response, because remember, we just returned a void. That means nothing. Okay. And then if you want to check, if you want to prove whether this was a success in reality, whether this was added to our list, all you have to do is just search it by ID, either 101 or get all learners, where just 4 were returned: John, Nargis, Sandeep, and Abhishek. When you hit send, and that is what you see at the end. Walid is now coming as part of a response, and you can even search it here by ID. I'll say learners 101. Hit send, and this is the proof that you need, that yes, it was added. Let's add one more, and I'll say, for example, 103, which is again not there, and we'll just add another one. Let's say Neha, and we'll say Neha has the skills currently Python. Hit send, 200 OK, go to get all learners, send. You see the new 2 ones added as part of my JSON array. That is 2 JSON objects that are new: Walid and Neha with their skills. So this is how we do the add new resource. And in our case, again, that resource is a learner. right? So it's just coming on really nicely for us. So now let's focus our attention to update a learner. And this time the request type is going to be of type put. The URL is the same as for getting a learner by ID, and this time we should be able to update an already existing learner. So let's go on and focus on that. What I'm going to do is I'm just going to add one more method here. Again, void, because all I need is the code that is 200. If that is responded with, so I know my request was a success. So I'll say void update existing learner. I'm always up for putting better readable and relevant names, identifiers. So this just tells anyone reading my code what this method would do. Update existing learner. And this time we have to pass in two arguments. The first one is a path variable. For which ID are you trying to update the learner for? So I'll say integer ID, path variable, and then this time again request body, because we would need the new learner object to replace the already existing one. Makes sense, right? And then the logic for updating an already existing learner. So again, I'll just use the post Java 8 stream and lambda strings syntax. So I'll say list of learners dot set. So there's a method called set in the list, which just takes the index and the object, and it would just update this object at this particular index. So we first have to find the index. So for that, I have another method in the list that is index of, and it takes the object where you want to update. Now we don't have the object yet. Let's get it from the stream syntax, the same syntax I wrote for getting a learner, searching a learner by ID, right? So I'll just say list of learners dot stream, and then dot filter. Again, it's actually the same as you wrote above for getting a learner by ID. So dot filter, and then we'll say ref dot ID dot equals the ID that we would pass. Okay, and then we'll say find first dot get. It gets me the learner by the index. Okay, and then you pass in the object to update, right? At this particular index, please update with the new learner object I'm passing. And we're not going to say return because we don't need it. We just need the code 200. So this is the logic for updating a learner at a particular index. And I can just put it on different lines so that you understand it appropriately. What's going on here? Find first dot get and then update it. Okay. Now, what is the request mapping going to look like? Either you use the generic request mapping, but then you have to say value and the method to put, or we have an appropriate request mapping subtype, and that is at put mapping. Yeah, which just needs the URL path. And I'll just say slash learners slash we need the ID as a template variable, as a placeholder, which this is mapped to with at path variable, and then we'll also pass in the request body a learner object. And this is again where you, if I don't know if you noticed, when we were passing as part of the post mapping, that is the learner object, we were passing it as a JSON object from Insomnia. See, it was a JSON object. But the beauty of Spring Boot is that it automatically, through at request body, converted it into a Java object, a JSON object into a Java object. You did not need to do anything extra. That is again the effortlessness what Spring Boot provides us with. And it would do the same here. It would take a JSON object and automatically convert it into a Java object. Okay, and we're ready. Let's rerun the application and just go on and test it on Insomnia whether this runs successfully or not, like we were able to run the previous 3 REST endpoints. Now we are exposing one more REST endpoint. This is throughput for updating an already existing learner. Our application is a success. Let's head over, create one more request, that's HTTP request, and this time I'll again paste it. Sorry, I'll paste it Let's get it from here, or we'll just get it as a drop down. Yeah, learners, but this time it's a put. So remember to select put here and the ID that we want to update. So let's say we want to update, click on get all learners again, and we want to update, for example, for John. So let's copy this JSON object as well, so that it makes it easy for us to just go on and paste it and make the changes whatever we want. Remember, later on it would come as a form, right, as parameters from a form request. So for now we're just testing our backend. So I'll just go on to body JSON and paste it. The ID is 56, which would be taken with the @path variable. Okay, and this would be as part of the request body. So ID 56, we generally don't tinker with the ID. Name John, I'll just say John Stewart. We're updating this, and C++ and updated. Updated why? Because we would know this was updated later on. This was not the case initially. Okay, so keep it to put, pass in the ID you want to update, and then just the new JSON object. I'll hit send. We get a 200 OK, and let's see if it was a success. Get all learners and say send again, and you see that ID is still 56, but John was changed to John Stewart, and then skills C++ and updated. So that means it has been updated in the list. Then the last one that is remaining is delete an already existing resource. In this case, again, learner, and the ID should be the same. That is the path learner/ID, but the method should be delete. So let's actually do that. I'll quickly create one more method, return type void. I'll say delete existing learner. And this time we just need the ID. We don't need the object, right? We just need to search it on the basis of ID, and that is what should be deleted in our list. And again, I'll just keep it to the same syntax, that is list of learners dot the method remove. Takes an object. I currently don't have it, but I need it with, I would get it with an index. So I'll say list of learners dot index of. First get the object by an index, and then let remove do the job for you. So again, the same syntax as above. Let's copy that until get, so that it finds the object at that index, and that would just do it for you, and it would just remove it. And we'll just say appropriate annotation, that is delete mapping, rather than the generic request mapping. And again, I'll say it should be to /learners and then a template variable, that is ID, which would be mapped to this ID. And we're done here. Let's quickly go on and rerun the application. To just be done in a second or so, and you're seeing that on the console. And let's head over to our Insomnia window. Let's put this to, rename this to update learner, and let's create one more for delete. Let's rename it again, delete learner. Rename it, and the URL again, it's going to look like with ID, this one. And let's first search what we have got here. Let's say we want to delete Nargis with ID 432. Let's go to delete learner and just pass in the ID as part of the URI. So let's say 432, hit send, 200 OK. This is all we needed here, right? The request has succeeded is what it's saying. Let's go to get all learners to prove that out, and we just, it still is returning Nargis. Let's see what went wrong here. If we go back to our IntelliJ window, let's see if we have done it right. I'm saying dot remove list of learners dot index of list of learners dot stream dot filter ref dot id dot equals id dot find first dot get. I think this is right. and we pass the ID as well. It's a void. It's a delete mapping. Should be done. Why didn't this delete it? Let's see. Let's go to delete. See, I forgot to put that as a delete. It was still the by default get. So now we say send. It says nobody returned 200. Okay, let's prove it out in get all learners. We should not get Nargis now, and that is what we don't. Let's try to delete Abhishek as well with the ID 578. This is still there. All you need to do is just click on that and pass in the ID, that is 578. Hit send, 200. Okay, just prove it in get all learners, and we just have 2 instead of the original 4. John and Sandeep are still remaining there. So now our complete REST API is done. All the 5 operations for get, post, put, and delete. We were able to get all learners. We were able to get a learner by ID. We were able to add a new resource, that is a learner. We were able to update and delete as well. This makes it a complete REST API. All the CRUD operations are done, and you now saw that as I said at the beginning, how effortless is what Spring Boot makes it for you. You don't even need to marshal and unmarshal from JSON to Java or from Java to JSON. Does that implicitly, automatically for you. And then you saw how auto scanning does the purpose. Auto configuration is there. You just need to put in at RestController, at RequestMapping, at Spring Boot application, and that's done. And when you take this example forward, just a note here is that generally we don't put any database specific operations in the controller. Currently we did not have a database, but even a static list, we should generally have done it in a different layer, that is a business service, where we would just have put at service on top of the class. And because the role of the REST controller should always be to listen and intercept incoming HTTP requests and then forward it to the service, which does the rest of the job. So I mean here, you just take it out, this particular code for having a list, put it in the service, and then just call the service methods that would do actual job on the list, not the controller. The controller is just having these request mappings, get mappings, delete mappings, add and put mappings for particular requests. But again, this is how we complete this tutorial with creating a REST API with Spring Boot. I hope you now have a good understanding of what Spring Boot is, how to create a REST API with Spring Boot, how to expose different functionalities of your application. So there you have it. That was about Spring Boot. We started from scratch and took it to a complete REST API with all the CRUD operations taken care of, and all of that was done in the most effortless of manners. That's it from me for this tutorial. In the next one, I'll be talking about how do you connect your Spring Boot applications to a database, and trust me, that is going to be one magical ride. So stay tuned for that. A sub to the channel at this point would be effortless.